Okay. So Hamza, you also talk, huh? I think you are going to be silent. You're not going to be silent now in my class, Hamza?
No, no.
No, no. Okay, fine. Acha, what are your subjects? PCB, PCM,
PCM,
PC, PC, BM,
PCM, physics, chemistry, and maths.
physics, chemistry, and maths. And there must be one more subject.
And engineering graphics.
And engineering graphics. Okay, fine. So where are you in Qatar? Like MES school? MES or some different
Yes.
school? MES only. Okay.
Yes.
Okay. So all of you can. So we are going to start solid state. Okay. And in solid state, we are first of all going to learn a few things and revise and review a few things that we already know. Okay, that we already know. And most important shape in solid state is the cube. Okay, the cube is the most important state, and you will be uh, meeting cube many times in this whole class. So this first class is very important. Okay, now this first class, you have to remember the first class as it is. You have to remember the whole class as it is. Okay, and let us start with cube. Let us start with cube. And tell me how many corners are there. I want answers from both of you. You can turn the mic on and tell me how many corners are there in a cube.
Sir, 8 corners.
Yes. Hamza, what did you say? 8? 8. How many edges?
12.
Yeah. Right, Hamza? 12 edges.
Yes. Yes.
Okay. How many faces?
6.
Faces, 6.
6 faces. How many diagonals?
2.
2.
Sir, 4.
Okay. 4. Okay. So there are 2 different type of diagonals that you can see. So the cube, it has 6 faces, and each of 6 face is a square, right? Yes or no? All of the faces are square, right, guys?
Yes.
And one square can have 2 diagonals, correct?
Good.
So each square will have 2 diagonal, and in the face you will have a face diagonal. So the number of face diagonals, the total number of face diagonals in a cube, it will be equal to 12, because in each faces there will be 2 diagonals. Now there is one more type of diagonal that can exist here. Okay. So if I look at this point, right? So this point, and if I look at this point here, so these 2 points are opposite points, right? These are opposite corners, right? This is the top right in the front, right? This is, you can say, top, and how you are viewing the cube, top, and this is the right, and this is in the, let us say, front. Okay, and this will be bottom, and it is in the left side, and this can be in the back, right? Now, it depends how you are viewing the cube, but you can see that both of these are opposite corners, and the line joining opposite corner, it is known as diagonal. Okay, so if I join these 2 lines, let me join these 2 lines. Sorry, let me join these 2 corners. Okay, I have to take help of this part. So if I join these 2 corners, what I am going to get is a body diagonal. Okay, so we can have body diagonals also, and these body diagonals, there will be body diagonal, and since we are joining corners, and with 2 corners I get 1 body diagonal. Okay, with 2 corners I get 1 body diagonal. So with 8 corners I will get 4 body diagonal. Is that right? Yes or no?
Yes.
Correct. Okay, so you can have body diagonal that is coming from the 2 corners that is in the ceiling, you can say. In your room, if you look at your room, it is going to be a cube or a cuboid type of room. So you can say that the 2 diagonals, they will be coming from the ceiling corners, and they will be ending up in the opposite floor corners, right? So you have this as the ceiling corner and it is ending up here. Then again, one more will be here. And this will be ending up here, right? This will be ending up in this side, like the bottom back part. Similarly, you will have one here, which will be ending up here. And then you will have one here, which will be ending up here. Okay, so you will have, you can say this is the first one. Okay, this is the second one. And then you have this corner as the third, this as the third, this one is the fourth, right? So if you join the 2 2, then you will get the second diagonal. If you join the 3 3, you will get the third diagonal. If you join the 4 4, you will get the fourth body diagonal. So there are 4 body diagonals. Now let us look at the length of these. Okay, so please don't write anything. I will give you time to write. Okay, right now just listen, don't write anything. And let me also make a face diagonal here. So if you join these two corners, this is going to be face diagonal. And the length is going to be, let us suppose for cube, the edge length is A. The edge length is going to be A. So this length here, this is also going to be A, right? Now, all of you can see this green line in your floor now, the floor of your room. Can you see that?
Yes, sir.
This green line you can see. And you can also say that this is 90 degrees. So this will be a hypotenuse, right? So this is our face diagonal. This face diagonal is a hypotenuse. And you can write the face diagonal square. It will be equal to A square perpendicular plus A square, that is the base, right? So this will be equal to 2A square. So face diagonal square is equal to 2A square. And if you write face diagonal, this will be equal to under root of 2A square. So what will happen? The A will come out and you will get A root 2. Any doubt in
No,
the
sir.
length of face diagonal? Okay. What about Hamza? No doubt, Hamza?
No, no, sir.
Okay. So face diagonal, the length of face diagonal is A root 2. Now let us calculate the length of body diagonal. Let us calculate the length of body diagonal. Now, if you look at the body diagonal, first of all, I want your attention in this edge. Okay. This edge is between the two walls. Okay. So this edge is between the two walls and this green line is in the floor. So this edge and this green line both will have a 90 degree, yes or no? Your wall and the floor, they have 90 degree, yes or no?
Yes.
This edge is on the wall, this green line is in the floor. So this will also be 90 degree. And we know that this green line, it is A root 2. Oops, sorry. Draw and green line, this is A root 2. And this black line here, it is A. And this is our body diagonal. So we can write the body diagonal square, it will be equal to the perpendicular, that is A, that is the edge, plus our base is A root 2 whole square. Now this will be equal to A square plus root 2 square will be 2 and A square will be A square. This will give me 3A square, correct? And then we can write body diagonal. It is equal to under root of 3A square. Now under root and A square, A will come out and you will get A root 3. So the length of body diagonal is going to be A root 3. Okay, the length of body diagonal is going to be A root 3. Now, these are the information that you have to remember and you cannot afford to forget it. What are these information? Corners are 8, edges are 12, faces are 6, face diagonal is 12 and its length is A root 2, body diagonals are 4 and its length is A root 3. So please write this down. Let me know when you're done by raising the hand in Zoom. Okay, all of you know now, both of you, how to raise hand in Zoom? Yes or no?
Yes.
Okay. Is that is done? Waiting for you, Hamza.
Yes, sir.
Done. Okay. Now, we are not going to leave cube. We'll be learning about cube. But now what I want all of you to think that these red dots, and these are atoms, okay? And these are special type of atoms. Atoms will not be placed as a very small points. So if I draw a cube like this, sorry, not this. So the atoms in this, they will be large, and the atoms, they will be covering a lot of space, right? And they will be placed in the corners. So if I join the midpoints of the atoms, okay, so they will be like this. Okay, so these are big atoms, right? And they are present in the corners, so they can be present also in the center of the face. Okay, they can also be present here, right, in the center of the face. Okay, so they can be present here, like center of the face. Okay, they can be present in the edge center, many places. Now what I want to do is I want to look at the contribution or the portion of these atom inside. Okay, all of you can see now that all of these atoms that I have selected, you can go to this here. So these atoms, they are not totally inside the cube, right? Yes or no?
Yes, sir.
So I want to know what portion of the atom, if it is present in the corner, is present inside the cube. Okay, what portion of the atom, if it is present inside the at the face center, then what portion of the atom is inside the cube? Okay, so let me just delete this part, and now let us think. Now, without even writing anything, I want both of you to look at the top left corner of your room. Okay, top left corner of your room. Fine. So what you will see, the corner will be like this. So this is the edge. Here is the one. Here is one wall, and here is the other wall. Okay, and then these two walls are making the ceiling, right? Yes or no? So this will be the corner,
Yes.
correct? Okay. Now, this same corner, it will be present in the other room also. The room just adjacent to it. Yes or no? Correct?
Yeah.
Think.
Yes, sir.
Yeah.
Right. Okay. Now, let us suppose that we have rooms. We have just rooms, nothing else. Okay. We just have rooms. So this corner was present in this room. It is now also present here. Okay. In this particular room. Now, we will have two rooms just in front of these two rooms. Okay. And this corner will be present in those two rooms also, right? Can you see that now?
Yes.
Okay. Now these are present in all the four rooms. This corner is present in all the four rooms. Now we will not even stop here. We will make a next floor. So if I make the next floor, all this corner will be present in all the four rooms above these four rooms. Yes or no? Like this. If I make a wall here like this, then you can see that this point here, it is also present in the above floor. Can you see that? Yes or no? Tell me, guys.
Yes.
Yes.
Right? So you can say that our corner, if you have a corner, it is present in how many rooms? It is present in four rooms of the floor and then four rooms just above. So it is present in 8 rooms. It is present in 8 rooms. So corner, since it is present in 8 rooms. So let me write corner. Okay. Now, if the corner is present in 8 rooms, the atom, if an atom is present at corner, the atom will also be present at 8 rooms, yes or no?
Yes, sir.
Now, if an atom is present in 8 rooms, then in one room, 1/8 of atom will be present.
Yes.
Okay. Now this is what you have to remember. Okay. This is what you have to remember. The contributions. Okay. So the topic is what? Contributions. So if you have a corner atom, so the corner atom, its contribution in one room is how much? It is 1/8. Okay, it is 1/8. Now let us move on and let us talk about the faces. Okay, so if you have a face, that means you have a wall, right? So a wall is present in one room. You can look at any of your walls. So the same wall, it will be present in the next room, adjacent room also. Yes or no? So if this is your wall, if you're in this room, the next room here, it will also have the same wall. Yes or no? The bricks will be same, correct? So a wall is
Yes.
shared by two rooms. A wall is shared by two rooms. Yes? Yes or no?
Yes.
So if you have an atom in the face center, that means if you have an atom in the wall, then it will be shared in two rooms and each room, its contribution will be 1/2, correct? Right,
Correct.
guys? Now let us suppose that it is present, an atom is present in the edge center. So this is our edge and it is present here. It is present here. So you can see that this edge is present in this one room, second room also, and the same edge will be present in the room above and this room above. So it will be present in the third room and it will be also present in the fourth room. Yes or no? The same edge.
Yes.
What about Hamza? Can you see Hamza? Yes or no? Tell me. Yes, Hamza?
Yes, sir.
Yes. So edge center. So edge is present in four rooms and hence its contribution will be 1/4. Now, if it is present in body center. Okay, so the atom completely is inside the room or it is completely inside the cube and hence the whole atom is inside. So that is why the contribution will be 1, right? So that means the whole atom is inside. So you can write this down, contributions. So corner atom is 1/8, base center is 1/2, edge center is 1/4 and body center is 1. Okay.
Okay, sir.
You can also write in bracket, just to remember, corner is shared by 8 rooms, है ना? Or you can write cube. Okay, similarly, you can write face is shared by 2 rooms or cube. Right, edge is shared by 4 room or cube, है ना? And body center, that means the whole body, the body of the cube. Inside that we have one atom. It will be only be available to that that cube or that room, nothing else.
Okay, sir.
Done all of you? Yes or no?
Yes, sir.
Okay. What about Hamza? Done?
No, sir. One minute.
Okay.
Okay, done.
Now, next thing that we want to learn is I will ask you 2 questions, simple questions. And it is not a question, rather, what do you think? Okay. So, what do you think? Okay. What do you think? Is there any vacant space in solids? Film.
Yes, sir.
Yes or no?
Yeah.
There are. Okay. Hamza,
Yeah.
what do you think? Yes,
Yes.
Hamza? Yes, there are. Okay, fine. So there are vacant spaces. And what are these vacant spaces called?
Voids.
Void. Okay, fine. So in your school, solid state is going on. What about Hamza? आपके school में क्या चल रहा है?
We're doing the second lesson.
Solutions. Huh,
Okay.
Hamza?
We're not in this lesson.
Okay, so this lesson is done or it is not done?
No, it's not. We didn't even start.
You did not start. So you started directly solutions chapter. Okay, fine. So different schools, they take different courses, but what I feel good is to take the sequence of NCERT, not any other thing. Okay. So Hamza, you also think the solid will have vacant spaces, right? And if somebody will argue that it cannot have, then you can ask them what do they think is the shape of atom. So this atom will be a sphere, right? The approximation will be a sphere. Atom is going to be a sphere in 3D. And you can have iron blocks which are cubical or which are cuboid in shape, right? Which are cuboidal in shape. Now, if you want to fill spheres into cube or cuboid, then you can imagine a room in which you are filling in footballs, right? You're filling footballs in room. Now, there can never be a possibility in which you are filling footballs in a room and you don't have vacant spaces. You are going to always have vacant spaces, right? Because when you fill a sphere inside room, there will be vacant spaces between the footballs. Yes or no? Correct?
Correct.
Now, moving on to voids, you'll be studying voids. And now let me tell you a pattern. Okay, let me tell you a pattern in studying things. If you look at mathematics and you ask a mathematician a point, what is the dimension of point? Sorry. They will say that it is dimensionless. We can say it is zero dimension. It has zero dimension. It neither has length, width, or height. But if I take two objects of zero dimensions, so I have taken two objects of zero dimension and I join them. So now I got a 1D object. Yes or no?
Yes, sir.
Now, if I take two 1D objects, if I take two 1D objects and join them. So if I will join these two, I will get a 2D object, right?
Yes.
Now, if I join two 2D objects, if I take two 2D objects and I join them, I will get a 3D object, right? Yes or no?
Yes.
Now, this is how mathematicians, they study higher dimensions also. So what they do, you can also take two 3D objects and you can join the points. Okay, now it is important which are the points that you need to join here, okay, in order you need to join. So as you can see, in 2D, we did not join the diagonals, opposite columns, right? So you have to bit only, I'm not going to try to do this, okay? So let me give the 4D to mathematicians. So what we can say that these are the higher dimensions and these are the lower dimensions, right? So you can, one thing you can see is that all the higher dimensions, they are made up of lower dimensions, right? Yes or no? All of these
Yes.
higher dimensions. That is why it is very important to study the lower dimensions. If you have a command, if you have expertise in lower dimensions, then you can, sorry, wait a second. You can predict, or you can also study the 3D or higher dimension objects very easily, right? So here also what we will do when we are studying about voids, so what we'll be studying, we'll be studying the voids that are made by 2D solids, and then we will be studying about 3D solids, right? So let me start voids, and I will classify voids into two types. I will classify voids into two types. Void, we have 2D voids, and we have 3D voids. Now, to make voids, I will first of all need atoms. So I will be showing atoms in this way. Okay. Now there is a difference when what is the difference between these two circles? Tell me, that I have placed in 2D void and 3D void. Is there any difference?
No, sir.
No, there is a difference. What is the difference? If I place a circle in the context of 2D, it means it is a circle. If I place a circle in the context of 3D, it means it is a
Okay, fixed sphere.
It's a sphere. And circle, the space occupied by circle, it is known as area because it is 2D, and it will be equal to pi r square. And if you talk about the space occupied by sphere, it will be volume, and it will be equal to 4 by 3
cube.
4 by 3 pi r cube, right? 4 by 3 pi r cube. Okay. No doubt till here, right? Hamza, Zaid, everything
Yes.
clear?
Yes.
Okay. Now let us move on to 2D voids. We'll first of all study the first 2D void, and rather than giving the name, I will draw the 2D void. And here we have one atom. I will place an atom just adjacent to the first atom, and then an atom between these two atoms. So I hope you can see that there is a void here. This is the void, right? The vacant space. Yes or no?
Yes.
Okay. Now, how to name this void? We have identified, okay, fine, this is a void. How to name it? So the convention that chemists have come up with, chemist and physicists also, because physicists, yeah, not physician. There is a difference between physician and physicist, right? Yes or no? You guys know what is the difference between physician and physicist? Nahin. No, Hamza and Zan?
So confused. Yeah, confused.
Confused? हाँ तो ये
Yeah.
homework आप लोगों को है ना थोड़ा this will be a homework. You learn about what is the difference between a physician and a
Like,
physicist. Okay?
physicist is a person who does physics. Like,
How does physics? What about physician?
physician, I don't know.
Prescribes the prescription. He gives
Yeah,
prescriptions.
he describes.
There are, yeah, exactly. So physiology, the human physiology, who studies the human physiology, he is the physician, and the one who studies physics is the physicist. Okay, fine. So solid state is also a part of physics. Okay, so if you go to higher classes and you want to study physics, then you will have a solid state physics, a semester or a chapter at least. Fine. So how are these named? So what we take the midpoints of the atom that are making the void. Okay, and then we join them. And when I join the midpoints of atom making void, I will get a shape. And this shape gives the name of void. So this is a triangular void. This is a triangular void. Okay. No doubt till here, this is a triangular void. Now we have another property or attribute of voids that we have to remember. And this attribute is going to be very much, you will be meeting again this one very often. Coordination number. So let me tell you, in general, whenever you hear this coordination number, this word coordination number, you should ask yourself how many atoms does it touch? Does it touch? Okay. Now you have to focus on this word it. So it will be changing. You know? What will happen? It will be changing. Right now we are talking about the coordination number of void. After a while, we will be talking about the coordination number of atom. Okay. But the question will be same. If I ask about how many atoms does void touch, then you will tell me, in this case, triangular void, the coordination number is going to be how much? 3, right? Yes or no?
3.
Right, 3. Now also you can say that for voids, it is very easy because the coordination number, it is equal to the number of voids, sorry, the number of atoms that are making the void. So coordination number of void is easy. It is always the number of atoms making the void. So let us move on to the next 2D void. Okay, this is the only two things you have to identify, you have to name. So what I will do, I will draw the second void, that is second void, which is, let me see, yeah, I have, okay. I will draw this void. You will tell me the coordination number, and after that you will tell me the name of this particular void. Okay, so all of you can see that this is the void here, and if I join the mid, okay, what is the coordination number? Tell me.
4.
Yeah, coordination number of void is equal to 4, and if I join the midpoints, then I'm getting a square, right? Yes or no?
Yes.
So this will be a square planar void. Okay, so see, you don't have to push much effort, right? You will see identify the void, and you can also name it very clearly. Let us move on to 3D voids. Let us move on to 3D voids. Okay. So in 3D voids, what I will do, I will first of all take a triangular void. And here what I will do, as soon as I have made these these three circles in the context of 3D, they have become spheres. And you can imagine I have three footballs that is lying on the floor, and then I take another football and I keep it on top of it. Correct? And I have kept it on top of it. Right? Now I have got a void, and what I will do in order to name it, I will first of all take the midpoints here. So these are the three midpoints, and then I have a blue atom above here, right? If I join the midpoints now, for you guys, it will be a bit difficult because you guys don't know this shape. I mean, you know the name of the shape, but you have not identified the shape. Okay, so what do you think? What is the shape?
Tetrahedral.
Correct. This is tetrahedral. Okay, this is going to be tetrahedral. But generally, you know tetrahedral in this way, right? This is
Yes,
tetrahedral to you, but please remember that these two things are same only. Okay, these two things are same only. Rather, this shape is tetrahedral and this geometry is tetrahedral. Okay, this geometry leads to a tetrahedral shape. Fine. So this is a tetrahedral void. Tetrahedral void. What will be the coordination number?
4.
Yeah, again 4, because 4 atoms are making this tetrahedral void. Now let us move on to the next void. And for that, I will copy this part of square in the void. But again, as soon as I will paste it here, these circles, they have become spheres. So what you can imagine there are 4 spheres lying on the floor, 4 spheres lying on the floor. And what I will do, leave it a second, wait a second. You can get this a bit above, I think. Yeah, we copy this, paste this, change the color, reduce the size. And I took another set of 4 footballs and I will place it on top of these 4 footballs. Okay. So their sizes will be same, but in order to show you guys, there is a red football and there's a black football. I have reduced the size of red football. So we have black football in one layer, then we have the red football. So if I want to draw the midpoints, I will take the midpoints like this. And then we have black atoms here and here. And similarly, we have red atoms just on top of it, right? Just on top of it like this. And if we will join the midpoints, sorry, if I join the midpoints like this, what shape is can you see? Cubical void, yes or no?
Yes, sir.
Coordination number will be
8.
coordination number will be 8. Now, let us move on to the next void. Now in this also you will have a similar situation. Initially I will take these 4 black footballs, but in the previous case they were lying in the floor, but right now they are not lying in the floor, they are above the ground. They are above the ground, and you can imagine that there are a few people who are holding it. There are a few people who are holding it. And what I will do, I will call another person and I will ask him to keep this blue football on top of 4, but I will not be keeping it right now in this. I will be showing that it is kept by these dotted lines. Okay, so this red football, it is being kept on top of these 4 footballs. Okay, and these 4 footballs are above the ground. Similarly, what I will do, I will take this same football. I'll take another football and I will place it from down. Okay, so, and I will place it from down. So you can see, and if I plot them, these are the midpoints. You have one football above, and there is another football here. Okay, so this also you will say that for you it is octahedral when I will join these lines, right? Now you will see it is
Yes.
octahedral, right? But actually you have octahedral. Hedra means faces. Okay, faces. Hedra means faces, so it has to have 8 faces. So how it will have 8 faces? If you get this like this, okay, and there is one face, then you have got 2 face, then you have 3 and 4 face, right? You have got 4 faces now, correct? And there will be 4 faces from this bottom blue one also. That is why it is known as octahedral shape. Okay, but since you are more comfortable with this shape, I will be drawing that shape only, which is the shape from 11th standard, which represents the geometry. Okay, I need some other color. This is going to be octahedral void. What will be the coordination number, guys?
Again 8.
6 now.
1, 2, yeah, 6.
Octahedral faces are 6, but here we have 6. Sorry, faces are 8, but here we have only 6 atoms. So coordination number will be 6.
Yes.
Now, octahedral is a bit important because it can have, if you look at the octahedral void from a different orientation, it will look very different. It will look completely different. So for that, let me show you guys. Let me share another screen. Can all of you see this black screen? Yes or no? Tell me.
Yes, sir.
Okay. So I'll be making a few atoms here. Fluorine, 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 fluorine. That one fluorine here. I hope I will get a good structure. Yeah, okay. Now, in order to change the color, I will change the colors. Wait a second. Yeah. So this is octahedral, right? Yes or no? You have 4 atoms in a plane, 1 atom above and 1 atom below. Correct? Yes or no?
Yes.
Now, if I change the orientation and if I want all of you to look at in this manner. Okay, so you guys are looking at this in this manner. What you can observe here is that we have all the red atoms in the plane behind. Yes or no? The red atoms are going behind, correct?
Yes.
Right? And the blue atoms are coming out of the plane, and you can say that this yellow part, this is the void, and this is the void here, and these are the blue atoms and the red atoms. If I join the red atoms, I can make a triangle which is facing upward triangle. Correct?
Yeah.
And if I join the blue atoms, I will be making a downward triangle. Correct?
Yes, sir.
So whenever you see this type of arrangement, then you are looking at an octahedral void. Now this looks very different from the conventional octahedral void structure, right? Yes or no?
Yeah.
So you will remember this one. Okay, you will remember this one. But you have to remember this is octahedral only. We have just changed the orientation on how we are looking at it. So you'll remember this point also, because in this chapter you will not be seeing this type of arrangement or this type of orientation of octahedral void. You will be seeing this orientation. Okay, you will be seeing this orientation. So the thing that you have to remember is if you have this type of arrangement, a red triangle upward in one layer, and in the other layer we will have a different type of atoms, and they are making a triangle in the opposite direction. Okay. So if you have this type of arrangement, this is also going to be octahedral. This is also octahedral void. This is not octahedral void, but rather it is a arrangement that leads to octahedral void. That leads to octahedral void. So now we have learned all about voids. I hope you have not written anything, so you can write it now. Raise your hand when you are done, okay? Hamza, are you done?
Yes, I'm done.
Oh, you have to raise hand when you're done. Okay.
Oh, I forgot to.
So we are done with voids also. We are done with some information about cube also. Now let us try to start making solids. So whenever we have to study something, there are two ways. Either we can deconstruct it. That means we can break it into small portion and study it. Or what we can do, we can take the smallest portion that we have and then build the bigger thing. So the smallest portion, the smallest part of a solid that we know is the atom. So I will take one atom. And for a solid, I don't need one atom, rather I need multiple atoms. So if I take one atom and I place it just adjacent to other atom, okay, and then I keep doing this. Take this and I will place it here. Then I will take these and I will place them here. So while I am doing this, I can see that I am making a solid, but this solid is 1D solid. Can all of you see it is one-dimensional solid? Yes or no?
Yes.
Though this is also known as 1D packing, in which the atoms are packed in one dimension. So we have taken the horizontal direction and that we have packed these atoms. Fine. Now, there is only one question that can come from 1D packing, and it is the coordination number of atom. Coordination number of atom. So when I say coordination number of atom, then in the question, how many atom does atom touch? How many atoms does atom touch? So what they mean is how many atoms in 1D packing, okay, how many atoms are these atoms touching? So we are interested only in the atoms whose whole environment is being made. If I look at these corner atoms, so these corner atoms, their environment is not completely made because we can have an atom adjacent to this atom, right? And here also we can have an atom adjacent to it. But if I want to keep 1D packing and I look at any of these inside this bracket, curly bracket, these atoms, these are complete. Their environment is complete. I cannot add any atom adjacent to it. As soon as I add an atom here, it is not 1D pack. Now it has got a length also. This is the width that we have got, and if I add down, I will get a I will get a length also. Okay, so I will be looking at, when I want the coordination number, I will be looking at the atoms whose environment is completely made, which are specifically these atoms, right? So what do you think, guys? What is the coordination number of these atoms?
So write in 2.
Correct. So coordination number is equal to 2. For 1D packing, it is 2. If you look at any of the atoms, let us say this atom, it is touched by 2 different atoms. Okay. So the coordination number of 1D packing is 2. Now from 1D packing, we will move towards 2D packing. From 1D packing, we will move towards 2D packing. And as I am moving towards 2D packing, I can see that I will take this 1D packing. I will take this 1D packing. And I can place the atom just beneath the atoms. So I will have atoms under atom, or what I can do, I can put these atoms here also in the depression. Correct? Yes or no? These are the two cases
Yes,
that we
sir.
can have, right? So while we are going from 1D packing to 2D packing, there are 2 different options. So let me get those options first. So from 1D packing, we are moving towards 2D packing. And in 2D packing, I've got 2 different options. In the first case, we are having atoms under atoms. In the second case, I am having atoms under. So this part, I am calling this as depression. So this is a kind of a hole, or you can dig this. So this is depression. गड्ढा जिसे कहते हैं. Okay, atoms under depression. So if I look at atoms under atom, I can have this type of arrangement. Copy this and place it here. So this is 2D, है ना? This is 2D. Please remember that this is 2D. Learning about 2D packing. So all of these are still circle. They are not spheres. They have not gone to spheres. These are still circles. So let me paste it here. Now, the first thing I will ask is, what is the void that you can see? I hope you can identify the void. Yes or no? Tell me, what is the void here?
So is it octahedral?
अरे देख के बताइए, octahedral void 2D में है कि 3D में है?
It's in 3D. Okay.
है ना? Please see and tell, है ना? Don't remember and tell. जो भी क्लास में आपने पढ़ा, जो भी है, see and tell.
Square plane.
Okay. है ना? Hamza, you can also see, right? Square plane the void? Yes or no?
Yes.
है ना? So the void is square plane. Now, when I ask you the coordination number, you will choose any of these atoms, right? You can't choose the atoms which are in the boundary because their environment is not completely, they're not complete. So I will choose any one of these atoms. So let me choose this atom. And you guys will tell me what is the coordination number of this atom?
4.
Yeah. So this atom is touching 1, 2, 3, and 4 atoms, right? So the coordination number of this is 4. Now, these are the information that you know as soon as you have made this picture. Now we will name it. We cannot always say atoms under atoms packing, right? So we'll name it. So for naming, I will take this one layer and I will name it A. Now, since the first layer and the second layer, they are completely same, they're not indistinguishable, they have no difference, then this layer will be also known as A. This layer will also be known as A, and this layer will also be known as A. And hence I will give this a name, that is AAA type packing. AAA type. Please don't write anything. Just listen. Okay, AAA type. Now, let us look at the next case, which is atoms under depression. Let me take the atoms, get a set of atoms below it. I need to have some space. And some atoms beneath these. What is the void that you can see, guys? Tell me. What is the void?
Triangular void.
Yeah, correct. So we have the void that is triangular. Okay. Next, if I take now, when I ask coordination number, then you will choose any of these atoms, which is whose environment is completely made. If I take this atom here, if I take this atom here, then tell me what is the coordination number of this atom? How many
6.
atoms it is? Yeah. Hamza, आप नहीं दे रहे आंसर, क्या हुआ?
Yes, sir, I can hear you.
Okay. Fine. So this is 6. Now we have got a few information. Then we want to have a bit more of information here. Okay, a bit of more information. Now, when we are studying, okay, name it. Let's name it. So this will be A. This layer is different than the first layer, so this will be B. But the first layer and the third layer is same, so this will be again A. Now the second layer and the fourth layer is same, that is why it will be B. And this is AB type. Packing. It is AB type packing. Now atoms and solids, they will have millions of atoms, right? Each solid they will have not million. You know how many? It will have million of atoms. That means 10 to the power 24. Even if I take 1 mole of atoms, there will be million atoms. We are not going to study those many million atoms. What we are going to study? We will take a small portion from the packing, and that portion should be such that those arrangement of atoms should be such that if I repeat those arrangement, then I will get the whole packing. What do I mean by that? If you look at this part here, wait a second. If you look at this part, okay. If you look at this red part here, and if I repeat this red part in all the directions, that means I copy paste it, okay, sequentially, then I will get the whole packing, correct? Yes or no? Tell me, guys.
Yes.
Anna. So we can study this part, or we can also study, if you take this part, this rectangular part, then, and if you repeat this part also, then also you are going to get the whole packing. But what we are going to study now, these small portions, these are known as unit cells. So if you repeat a unit cell in all the directions, you are going to get the whole packing. The unit cell that we are going to study is going to be a bit special. So we are going to study that unit cell, which gives us the information about coordination number, Okay. So I will take this unit cell. Okay. So I'm going to take this blue unit cell. Why? Because if I take this unit cell, I have got the information of the coordination number also, right? There are 4, which is equal to 4. Now, the unit cell of AAA type packing, unit cell of AAA type packing is square. That means if I copy and paste this square, if I pack the, if I start packing this square, then also I will be getting a AAA type packing. That is why it is also known as square close packing. Square close packing, and this is in 2D. Okay, square close packing in 2D. Now, if I look at the ABAB type, and if I want the unit cell which gives me the information about coordination number, then I will be taking this type of unit cell. Let me draw it here so that I will get a good shape, and then I will place that here. See, so I will take this and place it here. Okay, so this is my unit cell. As you can see, the unit cell in this case is a hexagon, right? The unit cell in this case is a hexagon. Other unit cell that you can make for this packing can be a triangular unit cell, but this is not useful for us. We are not very much interested here because it is not giving me the information about coordination number. You can also have parallelogram, which can be a unit cell, right? This can be also a unit cell, but we are not interested because it is not giving me information about the coordination number. One more thing that I want you to focus is that if you look at the base layer, so this is one layer. So this layer, in this layer we have A atom, then we have the B layer, then we again have the A layer. Okay, so this is a pattern that you will be seeing often, that a unit cell, it should start with a layer and it should end with the same layer. So if it is starting with A layer, it should end with the A layer only. Okay, so you can see here also, and in this case also, it is always AAA. So you can take any, but this is one of the points in unit cell, that the layer that you start from, it should also be the end layer. Okay, so you guys, please copy these two lines: 1D packing, coordination number, atoms under atoms, and then AA type. Okay, this unit cell is hexagon, so this is also known as hexagonal close packing. This is also in 2D, right? So here we have, this is, the whole thing can be known as square close packing, SCP, in 2D, and this whole thing can be known as HCP in 2D. Done, guys?
Yes, sir.
Both of you? Okay, only Hamza is here. That's got disconnected. Okay, fine. Acha. Hamza, so I think you have to wait for a while, or what we can do is wait a second. Okay, just wait a second. Let me have my iftar at least. Bismillah. Okay. So Hamza, you have to wait for 15 minutes. I will have my iftar pre-maghrib and come back. We will write a few points and then we will be done with the class. Okay, fine.
Yes.
Okay.
Okay.
Zed, are you here? Yes, Zed.
Yes, sir.
Okay. I think Hamza, he left. Hamza, are you here or he left? He went to pray. Sir. He can delay, sir. I think some 10 minutes now. Okay, I will tell him after he comes. Okay. So, so you wrote this, right? Yes or no?
Yes, sir.
Okay. Now, here we have unit cell. So let me define unit cell. So we just have a bit left. I don't know why Hamza left. Unit cell. Unit cell. The smallest repeated unit. The smallest, let me write, smallest unit of a packing that when repeated makes the whole packing. Makes the whole packing.
Sir, can we say the packing as lattice?
That we will come on come later on. Okay.
Okay,
So
sir.
lattice, crystal lattice is actually when we define the packing in terms of represent them, the atom as points. Okay. So if we keep the atom as points, then we say that that is a lattice. Okay. So lattice is a representation of packing. Okay. It is a representation of packing.
Okay.
Nice. Okay. So this is unit cell. This is unit cell. So here we have square close packing, and hence this is square unit cell, and this unit cell is hexagon. Now, if I want to ask which is better, since we have two different cases and two different options, which is going to be better? So we have a concept for that, which is known as packing efficiency. How efficiently are these atoms packed? That is packing efficiency. Okay. So packing efficiency, it is a concept that is used to determine and used to compare which solid is better, used to compare two solid. Packing efficiency. It is also written as PE, packing efficiency. Now, packing efficiency is very simple. So if I have to compare two students, I will compare their marks, right? Yes or no?
Yes, sir.
Right, Zan? And if I want to compare two solids, I will compare their packing efficiency. So marks is what percentage marks? It is marks obtained by total marks. And here also it is in terms of space, but the funda is same as marks. Okay. Here it is space occupied by atoms of unit cell divided by total space occupied by unit cell into 100. So this is packing efficiency. There is another term which is similar to packing efficiency, which is known as packing fraction. Some books also refer this to as packing factor, atomic packing factor. Okay. So packing fraction or packing factor, it is equal to, if you remove the 100 from packing efficiency, you get the packing fraction. Okay.
Packing fraction.
This is your packing.
So if we remove the 100, then we will get the packing fraction. That's
Fraction,
it?
yeah, fraction. That's it. Okay.
Yes.
This is packing fraction. Hence, you can also write packing efficiency. It is equal to packing fraction into 100. Now, the last term in the context of packing efficiency is void percentage. Now, void percentage, or we also write this as free space or empty space. Okay, all of these things. Now, in questions, it is referred by different names, but it is essentially either void percentage or free space, and which is equal to 100 minus the packing efficiency. 100 minus the packing efficiency. So please write this down. Let me know when you are done.
Okay, so finished the writing part.
Okay, you're done. Okay, fine. Yes, yes. You can leave then. Okay, we'll meet tomorrow. Okay, then.
Okay, sir.
Okay. Assalamu alaikum. Bye bye. Take care.
Thank you, sir.
Thank you. Hamza is left, but
Okay, I came back.
Walaikum assalam warahmatullah. You can delay Asar a bit, na? Yes or no?
Yes.
You left at by my time 6:20. I came back at 6:22. Okay. We have not covered much. You just need to write a few points. So I talked about unit cell, na? I just wrote that same thing. So smallest unit of a packing that when repeated makes the whole packing. That is the unit cell. And after that, tell me.
No, nothing.
Okay. And after that, we started a new concept, that is packing efficiency, which essentially is used to compare two solids, which is better. So we will compare in tomorrow's class AA type packing or ABAB type packing, which is better. Okay. So packing efficiency, it is the space occupied by atoms of unit cell divided by the total space of unit cell. Okay, total space occupied by unit cell. So as you can see now in AA type, we have these atoms, they are having some spaces, right? So this space here, this space here,